So the first approach that we're going to talk about for achieving privacy, statistical privacy in a database is something called k-anonymity. And the definition is very simple. Basically, anytime you're making a query on a database, you want the result set to contain at least k records. So one of those would be potentially the correct answer if you're looking for a single answer to a query. And then k minus one of them would be the ones that allow for some sort of plausible deniability that you are the actual answer to the question. So for example, if we're looking for the single highest paid employee in the state of Maryland under a k-anonymity regime where k is equal to 10, you can't actually get that person's final salary. You would just get 10 records of individuals who make a lot of money, right? And then that person, whoever they may be, would have plausible deniability where they're one of the other 9. Now, this is important because there are things in a database that are partially identifiable of an individual subject, but may not uniquely identify them. And we call these things quasi-identifiers. Good examples would include things like the zip code for the place where you're living, the city that you're living in, but even more generic, higher level qualifiers like gender or race could be good quasi-identifiers. And all of k-anonymity is trying to do is help us to manage these quasi-identifiers so that it's very difficult to link them to some other data set that does uniquely identify our data. And the two techniques that we use in k-anonymity to achieve this are generalization, essentially taking specific information and making it less revealing, and suppression, which is essentially removing information that could not possibly be generalized. Okay? So to take zip codes as an example, you may have a whole bunch of zip codes, each of which, we'll just assume the 5-digit zip code for now, each of which are identifying a small subset of people, but if you remove the last 3 significant digits, so instead of 46060 and 46061, you just have 46 star star star, that makes the pool of individuals who would be potentially qualified by that zip code much larger. Similarly, with phone numbers, you can just remove the last 4 digits and you still have something that's useful, right? A 212 area code is different from some other area code, and it's a valuable piece of information, but it is not as valuable as the specific exact phone number. Now, some pieces of data cannot be generalized, and we just have to remove them. We talk about this as suppression. So names are a good example. You can't easily generalize a list of names. It may not be possible to generalize something like gender, and it may actually be impossible for you to generalize other unique identifiers, nicknames, that sort of thing. So one activity that I would typically do in class is to take this chart and have you try and make this a 3 anonymous for 1 attribute queries. Now, I still think this is a good exercise, and there is actually an answer in the slides that I've uploaded online. I probably will not show it here in the video simply so that if you are interested in this, you can look at the slides on Blackboard and figure out one possible solution for making this 3 anonymous for 1 attribute queries. But I do want to highlight what that means. So a 1 attribute query would be something like selecting the name from this table, right? Where the name is equal to some, for example, maybe we're looking for Blaine in this table and figuring out what are all of his other attributes. That's a good example of a 1 attribute query. Or maybe we're looking for all of the people who have fewer than 100 friends, right? This is a 1 attribute query. It doesn't really matter what any of this other stuff is. We're just looking at friends, and the qualifier is fewer than 100. Those are 1 attribute queries. And essentially, for any of those 1 attribute queries, we want to make sure that we're getting at least 3 results. A very good exercise, and the answer, or at least one possible answer, using generalization and suppression is available on the slides on Blackboard. So please take some time to think through it and give it a shot now if you can.